All right, so this is transformation matrices in three-dimensional space. Really fast, you want to treat each, you have to go back to the making three-dimensional points and vectors. You want to treat each corner of the box that you made to create the actual vector or point and make it into a matrix. And each row is a certain coordinate letter. So like the first row be all the x's, second row be all the y's, third row be all the z's, and then the first column will be the first point, and so on and so on. Okay. All right. So some pretty simple stuff here, ladies and gentlemen. I'm not going to waste any time, but this is just matrix math right here, and this is actually how they do complicated computer programming type stuff. Is they actually use matrices and they use it in 3 dimensions. Okay. All right. So translations make you add to each component of the matrix. So you're just adding to each component of the matrix. Simple as that. So if you're moving 3 to the right on the x coordinate, you add 3 to all the x coordinates. If you're moving down 2 for the y coordinates, subtract 2 from all the y coordinates. Okay. All right. Reflections involve multiplying by a certain identity matrix. Okay. Okay, so if you want to reflect about the YZ plane, okay, multiply by the identity matrix, but with a -1 in row 1, column 1, okay? All right. If you want to go about the XZ plane, if you want to have a reflection about that, multiply by the identity matrix, but with a -1 in row 2, column 2, okay? And if you want to have a reflection about the XY plane in 3-dimensional space, you have to multiply by the identity matrix, but with a -1 in row 3, column 3. So the identity matrix, for some of you guys that are probably looking at this going, huh? Okay, it's looking like this. Don't be scared. It's not that scary. 0. Okay. All right, so that's the identity matrix. So when I'm talking about the YZ plane, and then you need a -1 in row 1, column 1, that's just the -1 right here. For the XZ plane reflection, put the -1 here, leave everything else a 1 and a 0. And then for the XY plane, multiply, put a -1 here in the row 3, column 3 spot, but everything else is the 1s and the 0s. Okay. All right, now dilations is multiplying by a scale factor matrix with the k's in place of the 1s in the identity matrix. So in other words, all of these will be replaced by the k. Okay, so if you wanted to make something larger, make k above 1. If you want to make something smaller, make the scale factor below 1 but greater than 0. Okay, all right, and that's it for transformation matrices in 3-dimensional space. You guys have a wonderful day, and I'll talk to you later.